So sometimes we have 3 sets. So what do we do? How do we find the number of elements for 3 sets? So the next is, in case of three overlapping sets, let's say A, B and C. Got it? So how do we find the union of A union B union C? So how do we find, what is the formula to find a number of A union B union C? No? So when we have 3 sets and overlapping sets, how do we find it? Now in order to know or explain that, let's draw a Venn diagram here and let's build the formula according to the Venn diagram. So we have set A, we have set B and we have set C. So A, B and C. So now the whole is, this whole thing is A, this whole thing is B and this whole thing is C. So now, but we have all the 3 sets which are overlapping to each other. So let's explain this. So how do we find the formula of this? So first we can find the value of this whole unification A union B union C by just adding A plus B plus C, number of A plus B, number of B plus number of C. But then we know that all of this, we have an intersection here of these two, we have an intersection of here of these two, we have an intersection of here of these two. So we have to, since this portion is being counted twice, so we have to subtract this portion A intersection B, because this portion is A intersection B. Now this portion is A intersection C. Now this portion is B intersection C. Now if you look, this portion is very peculiar in a sense that all the 3 sets intersects in this area. So this portion is called as A intersection B intersection C. So if you see, all of this intersection are counted either twice or thrice. So so this shaded portions have been counted twice or thrice. So this shaded portion, the pencil shaded portion, has been counted twice. Therefore we have to subtract from here. As we count A, this and this portion are also counted. So you have to minus A intersection B, and then again B intersection C has also been counted twice as we count C and B. So number of B intersection C has to be subtracted. Also this portion has been counted twice when you counted A and C, so we'll have to subtract A intersection C. But then as we do that, as we subtract all of this, we have subtracted this portion, the red portion, the red shaded portion. This portion has been subtracted like 3 times. So we'll have to add this portion again. So we'll have to be added, it has to be added. So it will be A intersection B. Okay, so yeah, so this portion is the A intersection B. As these 2 intersects, this has been counted twice, so we subtract that. And this portion of B intersection C, B intersection C. So as we count B and C, this portion is being counted twice, so we'll have to subtract that. And this portion is called A intersection C. This portion is called A intersection C because as we count this and this, it has been counted twice, this portion, so we'll have to subtract that as well. But as we do that, as we subtract all of this portion, since it is common to all, of the 3 sets, therefore it has been subtracted extra. So we are adding that adding that in order to compensate the extra subtraction. So in conclusion, the formula to find number of A union B union C will be number of A plus number of B plus number of C minus number of A intersection B minus number of A intersection C minus number of B intersection C plus the middlemost portion, which one? This one. Number of A intersection B intersection C. So that is how we have to find the number of A union B union C. All right. So coming again in conclusion. So what is the formula of number of A union B union C? So what does it mean? It means this whole portion of this whole portion, the whole of it. So when we say number of A union B union C, actually we mean this whole thing. We mean this whole thing. So if you want to find the number of elements in this whole thing, what you have to do is you have to add this A, number of A, plus the number of B, plus the number of C. But as we do that, there are overlapping sets, there are overlapping portion in this set, and therefore this portions, which is A intersection B, A intersection C, and B intersection C, have been counted twice. So elements in these regions have been counted twice, so we have to subtract that. So as we subtract this, again, it leads to extra subtraction of this area, this portion. This portion has been subtracted extra. So what do we do is, at the end, we add this up because it has been subtracted extra. So that's why the formula at the end, the formula is number of A plus number of B plus number of C minus A intersection B minus number of A intersection C minus number of B intersection C plus finally A intersection B intersection C. So this is the formula to find number of A union B union C.